Hello, warm greetings and welcome to this presentation about Aruba AI operations. Quick overview of some of the topics that we're going to cover in this session. We will discuss some of the day-to-day challenges network operators continue to face, the importance of data and value of AI operations, and we'll wrap up the presentation with a real-world view of some of the problems and the use cases that our AI operations technology is helping customers solve. Now, with the massive adoption of cloud and IoT, the complexity of use cases and expectations for network performance, resiliency, and security continues to increase. The network management systems have evolved over the last many years. However, they continue to fall short of some of the proactive management optimization requirements of the modern-day large-scale network infrastructure that comprises wired, wireless, and SD-WAN, primarily because of the volume of data traffic and the diversity of use cases, devices, and applications that these network infrastructure elements as well as IT operators deal with on a day-to-day basis. Now, this poses several challenges for network operators. And it really forces them to grapple with a set of questions. Questions such as, where do we invest our limited time? What issues are causing the most pain for my end user community? But more importantly, what issues am I not aware of that potentially is lurking underneath the surface that could boil over and impact end user experience on a large scale? Now, artificial intelligence is becoming commonplace in a lot of the gadgets and equipment that we use or that we come across on a day-to-day basis. Examples include smartphone software applications, home appliances, and even cars that we drive around these days. Now, network management software can benefit significantly by the application of artificial intelligence technology to help network operations teams cope with some of the challenges and the types of questions that they tend to grapple with and help network operators overcome some of those challenges. Now, before we dive deeper into AI ops and the technology itself, let's kind of quickly get a perspective for what AI ops is all about. And what better way to start this discussion than to review the definition from Gartner. Now, Gartner Incorporated describes or defines AI ops, or artificial intelligence for IT operations, as AI ops combines big data and machine learning to automate IT operations processes, including event correlation, anomaly detection, and causality determination. Now, the terms AI ops and automation tend to get used interchangeably, or in some cases really get mixed up. Now, day zero automation is all about onboarding new network devices by means of zero-touch provisioning. But day one through day n monitoring and optimization use cases actually are an end result, or automation capabilities are an end result of consuming these AI insights and recommendations, defining operations runbooks, and being able to integrate workflows to trigger automatic actions through the IT service management systems. And that is how AI ops versus automation can kind of get distinguished in terms of day-to-day usage around various systems. Now, great AI operations starts with rich and diverse data. To build and train the machine learning models, we rely on hundreds of metrics related to users and network devices, metrics such as throughput, latency, resource efficiency, etc. Now, each of these metrics really quantify how the network is behaving, how well it's working, and in turn, how it is impacting the end user experience. Now, we have assimilated this data over many years across a vast range of verticals, like you see on the left-hand column here, including the unified infrastructure comprising wired, wireless, SD-WAN, and more recently, the data center infrastructure as well, across a broad range of client device types. Now, all of this rich data across this entire portfolio of verticals, infrastructure, and client devices has resulted in this massive data lake that we've been able to build up over the last many years. Now, we leverage this data lake to train new AI models really quickly by bringing to bear our tremendous experience with the domain, with the Wi-Fi and the networking domain in general, plus also very rich data science expertise. And all of this is backed up and evidenced by the hundreds of patents we have in a broad range of areas. Now that we've established the importance of data, let's look at how we bring all of these things together to facilitate AI-driven network operations. Our data lake draws upon telemetry from 1 million plus network devices, 55 million plus clients, and 65K plus customer networks or configurations. All of these contribute more than 1.5 billion records in a single day. And all of these data points or elements are going up or increasing by the day. Now, all this data gets analyzed by our machine learning algorithms and mathematical models to look for patterns, to understand patterns related to environmental factors, traffic characteristics, user and device behavior, and also be able to measure the overall end user experience. Now, these models are what powers what we call the self-driving network or the self-optimizing network. Now, the objectives of a self-driving or a self-optimizing network are twofold. First is to provide stable, resilient network connectivity. Second is to guarantee great end user experience with the highest quality of service. Now, in order to accomplish these two objectives for a self-driving or a self-optimizing network, the AI-driven network operations has to deliver outcomes that include automated root cause analysis, being able to preempt issues, that is, nipping issues in the bud while they're lurking underneath the surface or while they're just boiling over, and then be able to mitigate impact across a broad range of users. Next, prescriptive configuration recommendations for proactive performance tuning. And last but not least, taking the guesswork associated with configuration changes. That is, being able to quantify the before versus after and validate the impact of change. Now, AI operations for Aruba is one of the key 3 pillars of what we are calling, as part of this Atmosphere digital event that we have introduced to the market, that we are calling Aruba ESP, or the Aruba Edge Services Platform. The AI operations capability is part of the broader ESP portfolio and is integrated into the Aruba Central product capabilities. That is a single pane of glass for managing unified infrastructure around wired, wireless, and SD-WAN that provides zero trust security capabilities as well as part of this one integrated portfolio. Now, this AI capability built into ESP is what provides that extra sensory perception, or the sixth sense, to the network as well as the network operator. Aruba's AI capabilities have evolved significantly over the last 2 to 3 years and include things such as AI insights for automated anomaly detection, automatic root cause correlation, and proactive network optimization capabilities. AI search that includes natural language-based search queries to help a network operator to get to information that's of most relevance with the fewest mouse clicks. Beyond that, if they need advanced assistance, the same AI search or a live agent capability based on AI can ensure a context-sensitive transfer of the network operator and his or her troubleshooting views and sessions straight through to an Aruba TAC live agent. The third capability is what we call AI Assist, which revolves around the ability to collect logs and packet capture files for root cause analysis automatically, and more importantly, we also have the capability to open trouble tickets through the Aruba TAC systems and to the TAC organization. Last but not least, the newest addition is the AI-driven device identification and profiling capabilities, including IoT devices on the network, that helps define policies, access control policies, for dynamic policy enforcement. In Aruba, we call it dynamic segmentation for policies for users and devices. Now, we have talked a little bit about the importance of data and how Aruba's AI operations capabilities are built and how they come together, and some of the key value proposition capabilities that we offer for our customers. Now, next, let's look at how Aruba's AI Ops is helping our customers solve real-world problems and help them with some of the day-to-day pain points and use cases. Now, we're going to go look at 4 examples as part of this narrative. In the first example, we show how Aruba AI Ops is able to help resolve a wired network misconfiguration issue. But more importantly, we're able to show how it's not just about the AI capabilities and all of the insights, but it's also about how we can look at the before and after in terms of the end user experience that may have been impacted, and how once you implement the resolution steps, you can go back and validate that the potential end user experience challenges have indeed been resolved. And with this particular case, we were able to reduce the overall resolution time by about 90%. Now let's look at some of the Aruba Central screens into which AI operations is built into, and how these screens bring these capabilities to life. Now, as a network administrator or an operator, you can start with the main global dashboard view of Aruba Central that shows all of the different locations, office or other locations, where you have Aruba infrastructure deployed. And within this, we can see that one of the locations has a red indicator or an icon that denotes or that signifies there could be potential issues that are occurring at that particular site. Now, you could drill down into that particular site view. There are 2 things here on this particular screen that are of interest. First and foremost is what we're calling the user experience sad face with a red icon that you can see on the screen. And that is straight away telling us that the user experience sensors that actually are an overlay on top of the wireless or wired infrastructure that are able to run synthetic transactions and be able to provide you a proxy for the overall end user experience. Those sensors are reporting that when they connect to some of these APs in a particular location, in a small area, they're not able to receive an IP address because they're not able to reach the DHCP server. Similarly, we also see a red icon with an AI insight, potentially that might tell or give us more insight into what might be occurring at that site. Now, you, as a network operator, you can drill down into these insights for the next level of detail. And on this screen, we straight away see that the insight is telling us that there's a missing VLAN. And we also see the name of a particular switch. And equally importantly, next to the category and where we have the switch name called out with the missing VLAN information, you also see an icon that shows or that has recorded packet captures for when this particular issue occurred. And in the middle of the screen, you can look at the time chart that shows when these DHCP failures occurred. Further down, we show you which AP is this particular sensor trying to connect to. That in turn tells you, what area of a given building or a location this is impacting. And equally importantly, it's also telling us that 2 clients are also trying to connect to this AP, and obviously those clients, the real clients, will also be experiencing the same problem that the user experience sensor would be experiencing. Now, at this point, you can see that we have an apply fix little icon that is available, and the network operator at this point in time can go click the apply fix, and we're able to automatically go in and create the missing VLAN on the switch and map it to the port that the AP is connected to. So the connectivity or the misconfiguration issues that might have occurred inadvertently at that on that particular switch is resolved. And you can go back and, more importantly, validate the fact that the fix has taken hold and the issues are resolved, because you can go back and look at the user experience sensor data. Now, obviously, you see a green happy face, and the user experience inside is telling us everything is good. And this is a fantastic example of our AI engines or AI operations, not just looking at all of the data from a network perspective, but equally importantly, bringing in the data elements or data points from the user experience sensors that is independent of the wired wireless network, but it's constantly probing and testing the wired and wireless infrastructure to mimic the end user's experience of the network usage, and proactively be able to bubble up issues before they start to impact broad-based users. Now, we bought the user experience views, correlated that with the AI operations capabilities built into Aruba Central as part of the AI engine, and we're able to make this end-to-end correlation and also ensure there's closed loop once the issues are resolved. Now, let's look at a second example. In this example, we're going to review how Aruba's AI capabilities are able to provide proactive performance optimization recommendations based on peer group data or analyzing data for similar customers or similar deployment models. Now, in this particular case, the network operator, as part of their day-to-day activities or periodic checkups about the health of the network, can, for example, navigate into the AI Insights dashboard view. And we see here that there is one particular insight that's telling us that the access point transmit power recommendation. So there is an access point transmit power recommendation that is available. Perhaps the AI engine within Aruba Central has seen something that it sees there's room for optimization. So now you can drill down further into that insight. And what this insight is telling us is the 2.4 as well as the 5 gigahertz radios on access points are not running with the optimal transmit power settings. And our engine has been able to determine this by looking at various performance attributes and characteristics of users and devices that are connecting to the 2.5 gigahertz band, as well as the 2.4 gigahertz band, as well as the 5 gigahertz radios. Now, beyond that, we're able to make a very specific recommendation, and we're able to tell the network operator to go change the 2.4 and 5 gigahertz settings to the optimal transmit power levels. And we're able to do all of this analysis and make these prescriptive recommendations based on the fact that we're looking, as I said earlier, traffic patterns, traffic characteristics, the overall performance of the network, and comparing this particular deployment for those specific AP models in this location where we're seeing the issue versus the performance levels maybe at a similar building for the same customer, maybe in the same campus, or maybe from a completely different set of customers that are deploying or that have deployed similar APs in a similar overall building layout or geometry, if you will. And this is how our technology is able to make proactive optimization recommendations by doing peer group analysis. Now let's look at a third example. In this particular example, we demonstrate how Aruba AI Operations is able to deliver better performance or make recommendations to network operators to achieve better performance levels with their existing infrastructure. And in this specific case, this is a real-world use case that we were able to find a problem and mitigate the problem. The passerby traffic all of these users that kind of walk by or they're just passing by a particular AP, in many cases might fleetingly connect to an AP, and they seem to be tracking down the performance of all of the users that are kind of maybe not mobile or seated at their desk or what have you, and their performance being dragged down. And by doing all of this correlation, and we're going to show you how this comes to life and some of the proof points for how this capability works, we were able to actually increase the overall performance levels by about 25% in terms of the overall network capacity by opening up a ton of inefficient airtime that was being consumed by the passerby clients by the inefficient use of airtime or the spectrum, if you will. Now, in this scenario, and by the way, right, you could have passerby clients, even though this particular example applies to outdoor passerby clients dragging down performance of indoor clients. In reality, passerby clients could also impact the performance. For example, if you have APs located in highly trafficked areas such as elevator lobbies, users that might end up connecting to those types of APs or radios that are passing by could drag down the performance levels for all of the clients that are in the neighborhood, right? So in this context, what we're seeing here, first and foremost, is the client minutes. And we're seeing that about 73% rather, of all of the client minutes, right, for outdoor clients are connected at a lower than optimal SNR thresholds. And more importantly, the network operator also can go in and look at the fact that the indoor minutes with this light blue graph or teal graph are much subhigher compared to the overall number of minutes where the outdoor clients are passing traffic. However, the optimal connectivity, right, the SNR, the subpar SNR connectivity for outdoor clients is more than 70% of the overall minutes. This clearly is telling us that the airtime is being dragged down or is being used inefficiently because of the suboptimal connections. And once again, our AI engines or capabilities are able to make a prescriptive recommendation where we are telling the network operator to go change the probe thresholds as well as authentication thresholds to ensure that the outdoor clients don't end up, or passerby clients do not necessarily end up connecting to the indoor APs, thus dragging the performance levels for the rest of the clients that are actually need to transact business over the core mission critical wireless network. Now let's look at our fourth example and the last one in this series. In many cases, the problems themselves may not be something that are germane or are applicable to the wired infrastructure or wireless infrastructure. It could be because of other elements in the chain that could be impacting the overall network availability, reliability, and resiliency. So some of these cases could be very complex. Getting to the root cause is not just just one mouse click, and this is exactly where the Aruba AI operations capability is able to bring its power together and really make it a truly one-click correlation view without having to go try and chase an intermittent problem over and over again by collecting logs and data and packet captures or what have you. And we do all of this readily and make it available for the network operator to be able to go get to the root cause really quickly. So in this case, again, we were able to reduce the issue resolution time by as much as 90%. And let's look at how this feature set kind of comes to life. Again, the network operator can start with the global dashboard view. There's also a little bell icon with a red flag on top of the icon that is telling us that there are a bunch of alerts that are events that the network operator maybe needs to pay attention to. And now you can drill down on that particular icon. We see the standard set of alerts as well as AI insights driven alerts. And we already see that there is some issue related to an IPsec tunnel, if you will. The tunnel state is flapping and looks like it's been marked up or down intermittently. And now you can drill down into that particular AI insights based alerts view. And we clearly see here that tunnel state has changed, and we're clearly identifying the IPsec tunnel and the SD branch gateway in this case, right? So this tunnel has been established from the SD branch gateway at a remote location back into a data center in a VPN concentrator. and we see a file icon there that has already captured all of the logs by running a bunch of CLI commands automatically, plus also it has done a bunch of packet captures for the network administrator. And now the network operator has the option to download or email all of this data, the packet captures and all the raw data, to anybody else within their organization, or even to Aruba TAC if need be, as the case may be. And the email itself captures all of the metadata related to the site and other pertinent information with links to some of the more detailed troubleshooting and analysis files. And further, it has the capability to automatically trigger a trouble ticket, right, to Aruba TAC. And in this particular case, the issue, obviously based on all the data that we've been collected, it can be root caused to the fact that the service provider WAN link is unstable, and as a result, the IPsec tunnels are flapping, and we're able to get to the root cause. And now, obviously, you have enough information to go follow up with the service provider or figure out what might be happening with the WAN link. Now, we looked at 4 examples, one related to a wired insight with a VLAN fix, 2 related to proactive configuration recommendations for optimization, as well as to resolve intermittent issues with the passerby client use case, and the last one related to an SD branch gateway. This is how Aruba AI Insights is able to provide value across wired, wireless, as well as SD-WAN use cases. Now, to quickly recap and look and summarize the discussion so far, we've talked about the importance of data, first and foremost. We have explained why Aruba AI Operations is differentiated. It's differentiated because we have one of the largest data lakes in the industry with the most diverse data for clients, devices, network devices, deployment patterns. We have a tremendous amount of domain expertise, lots of rich data science expertise, but most importantly, we have the experience supporting some of the largest mission-critical networks over the last almost 2 decades. And we bring to bear all of these experience, all of this data, and all of this knowledge to enable AI ops to deliver 3 key broad outcomes. The first one, obviously, relates to known issue resolution, automated root cause analysis, and being able to mitigate issues without the network operations teams having to chase issues by trying to look at multiple systems or areas. Secondly, and very important, is being able to shed light on unknown issues. In many cases, issues will be lurking underneath the surface. It might be impacting a small subset of users and will not necessarily bubble up to IT administrators as a trouble ticket yet. So in our case, we're able to proactively bubble up those problems, provide prescriptive recommendations for resolving those issues before they boil over and impact users on a large scale. And last but not least, our AI models, algorithms, and data models are able to continuously analyze all the data, optimize, come up with recommendations to apply some of these configuration changes in a proactive fashion so that less optimal networks can be fixed and all of the networks run at the highest level of performance and capacity that they're designed for. So that essentially sums up the AI operations discussion. And I want to take a minute here to talk about the Airheads community. If you're not already part of the Airheads community, we obviously request and invite you to join the community at community.arubanetworks.com. And also, please take the time to give us feedback, not just about this presentation, but any aspect of your Aruba product or services experience. And obviously, you can use our app to be able to do so, and you can fill out survey questions and take other actions to communicate with Aruba and one of the Aruba team members so we can act on your feedback, advice, and recommendations. That really wraps up this presentation or a discussion. Thank you for the opportunity. Thank you for listening in. and I really hope that you found this presentation useful. Thank you. Good luck. Thanks for being an Aruba customer.